The height of an object in free fall is modeled by the function h of t is equal to negative 16t square plus s, where s is the initial height in feet of the object and t is time in seconds. Now, an object is dropped from a height of 81 feet. After how many seconds will the object hit the ground? Okay, it's a kind of long problem. It appears a kind of lengthy and difficult, but it is not so. It is just a basic quadratic function. We did a number of problems dealing with the complicated quadratics, and this is just one of them. So how do you do this? Given this h of t, so always we have to read the question once or two times for better understanding. So h of t is the function for a freely falling body. Okay, so h of t is equal to negative 16 t square plus s. Okay, now s is the initial height and t is the time in seconds. So what is the initial height that they gave us in this particular problem? In this case, the initial height is 81 feet. So our this s is equal to 81 feet, and we will substitute that 81 in this function. Okay, so h of t is equal to negative 16 t square plus 81. Alright, now this is the function h of t is equal to negative 16 t square plus 81. The given function is changed into this form just by substituting this s with the 81. Right, that is, you are dropping an object from this height. Let us say this is the ground level here, and from the top, from this point, an object is dropped, and this whole height or this whole thing is how much? This is 81 feet, right? That 81 feet you have here, it is this. Now, to reach from this height of 81 feet, any object, it needs some time to go. Like it can be 1 second, 2 seconds, or whatever time, but it needs some time. So that time we have to find. That's what they are asking here. After how many seconds will the object hit the ground? So on hitting the ground, that is once it reaches the ground, what is the height? What will be the height of the body that is at the ground level? There is no height only. So I have to take this h of t as a 0 here on reaching the ground. Now I'll replace this h of t as a 0. In place of this height, I'm writing down 0 is equal to negative 16 t square plus 81. Okay, so we have to find the time now. In this function h of t, you have now that height is given, that s, everything except the time. So at what time, that is after how many seconds, the object will reach the ground. So how do you solve this? You can change this into quadratic form and then solve it. So let us find the value of t by making use of our knowledge of quadratics. Now we have negative 16 t square plus 81 t, and on the left hand side I have 0. So what is the best thing? I think I will add 16t square on both sides. Adding 16t square, that gives me 16t square is equal to 81. Then take away 81 on both sides, subtract 81. That will give us 16t square minus 81 is equal to 0. This 81 got cancelled. We have 0. Then we can see that the 16t square and 81, those two are perfect squares. So I will write this as a 4t whole square. 16 is a 4 times 4 and t square. Okay, so it is 4t square minus this 81 is a 9 square. Okay, on the right hand side it is 0, and we have special product a square minus b square gives you a plus b times a minus b. So when you take the difference of two squares, then it is the first term plus second times first minus second. So using that formula here, 4t plus 9 times 4t minus 9. 4t minus 9 is equal to 0. So 4t plus 9, I'll write 0, and 4t minus 9 is equal to 0. Solve for t, take away 9 and take away 9 gives you 4t is equal to negative 9. Then divide 4 on both sides. So your time t is equal to negative 9 over 4 seconds. And the time cannot be negative. You can't go back. So this is a wrong t value. So let us do this. Add 9 on both sides. 4t is equal to 9 because this is gone. Now divide 4 on both sides. So the time t is equal to 9 over 4. 9 over 4, that is 2.25, I think. Let me see. 9. Okay, 9 divide 4. 2.25. So after 2.25 seconds, that object will reach the ground. That's what they are asking. Alright. So for this object to reach the ground from a height of 81 feet, it will take 2.25 seconds. So how did you do this problem? First I substituted s is equal to 81, and then this h equal to 0, and afterwards we brought it into quadratic form. So what we did in this particular case is just negative 16t square plus 81. From right hand side it is moved to the left hand side. That's why this negative 16t square became positive 16t square plus 81 became minus 81. And I showed that regular procedure for better understanding. And afterwards we made use of this rule, a square minus b square equal to a plus b times a minus b. So we got 4t square minus 9 square became 4t plus 9 times 4t minus 9, and then solved for t, and that is the time you got. But sometimes, like if you don't want, like, if you don't have to use this factorization all, directly from this 16t square equal to 81, I'll show you what I could have done is 16t square is equal to 81. I'm going from this step. Solve for t. So I'll divide by 16 on both sides. So 16 and 16 will cancel off, leaving behind t square. T square is equal to 81 over 16. Then how do you find a t? To find the value of t, I'll just take the square root on both sides. Square root of t square is a t, and the square root of 81 is 9, and square root of 16 is 4. Right, that's the same thing. And you are looking for only the positive square root, of course, because time cannot be negative. The same answer we get it here. But as you are all reviewing this quadratics, so we have to make use of quadratics when you are explaining this. And I also have it's a figure here in the next slide for this same function. H of t is equal to negative 16t square plus 81. Let me show it to you. See, the height, and initially this was the height. For 0 seconds, the height was 80. 80 plus 1, sorry, it's 81. That's what we have there, 81. And after 1 second, it will reach up to this. It is between 60 and 70, so it should be 65. And then after, see, it is the last one, on reaching the ground, it is between 2 and 2.5. Between 2 and 2.5, the average of those two, that is 2.25 exactly. 2.25 seconds it will take to reach the ground. The same thing you can also get it by using your graphic calculator. Okay, now I have one problem for you. The same situation, it is just the same. The height of an object in free fall is modeled by the function h of t equal to negative 16t square plus s, where s is the initial height and t is the time. In this case, it is the object is dropped from 100 feet. So after how many seconds will the object hit the ground? So please try, do it by your regular method like this one, quadratics method, and after that verify by using that shortcut also. So please try this one. Thank you.